Have you ever wondered how an engineering marvel turned into one of the world's largest nuclear disasters? Let's start at the very beginning. In the heart of the 1970s, an era of disco and bell-bottoms, the Soviet Union was making strides in a different dance, the dance of nuclear power. With a rapidly growing economy and an insatiable appetite for energy, the Soviets were determined to harness the atom's might. In the northern reaches of the Ukrainian SSR, near the town of Pripyat, a new chapter in this atomic dance began. Here, on the banks of the Pripyat River, the Chernobyl power plant was conceived, an audacious plan, one that would etch the name Chernobyl into the annals of history, though not for reasons they could have ever foreseen. The Soviets chose a reactor design for Chernobyl that was ambitious, to say the least. The RBMK reactor, a behemoth of Soviet engineering, was their choice. A design unique in its features, it boasted the ability to produce both plutonium and electric power, a dual purpose that was incredibly attractive at the time. However, with its unique features came inherent risks. The RBMK reactor was a high-power channel-type reactor, a design that prioritized power output over safety. Unlike its Western counterparts, it lacked a robust containment structure, a fact that would prove catastrophic in the years to come. Moreover, the RBMK's graphite-moderated core, while efficient in operation, was a ticking time bomb. It had a positive void coefficient, a fancy term that simply means if cooling water was lost, the reaction could speed up rather than slow down, a dangerous prospect in any nuclear setting. Despite these risks, construction pressed on. Over the span of a few years, the plant took shape, its 4 reactors standing tall against the Ukrainian skyline, a testament to the might and ambition of the Soviet Union. So, the Chernobyl power plant, an engineering marvel of its time, was born, oblivious to the fate that awaited it. The design and construction of the Chernobyl power plant was a feat of engineering on a colossal scale. The construction of this massive facility began in the late 1970s with the Soviets at the helm. It was a marvel of modern engineering, built to supply power to millions across Ukraine and beyond. The core of the plant was 4 RBMK nuclear reactors, a design unique to the Soviet Union. The RBMK, or Reaktor Bolshoi Moshnosti Kanalny, was a high-power channel-type reactor. It was a behemoth, containing over 1,600 individual fuel channels and a graphite moderator. The RBMK was chosen for its ability to produce both electricity and plutonium, a critical element for the Soviet Union's nuclear weapons program. However, the RBMK design had inherent flaws. Its positive void coefficient, a parameter that measures how a reactor responds to increased steam formation in the coolant, was dangerously high. This meant that if coolant began to boil, the reaction could accelerate out of control, rather than slowing down, as in other reactor designs. The construction materials used were of varied quality. While the reactor's pressure tubes were fashioned from zirconium-niobium alloy, the building itself was a mix of steel and concrete, with no containment structure to prevent the escape of radioactive materials in an accident. This was a significant departure from Western designs, which prioritized containment above all else. Safety measures were in place, but they were insufficient. The emergency cooling system was designed to handle small leaks or blockages, not a full-scale meltdown. The control rods, designed to absorb neutrons and slow the nuclear reaction, were tipped with graphite, ironically increasing reactivity during the initial stages of insertion. In the end, the design and construction of the Chernobyl power plant was a testament to the technological prowess of the time, and yet it was a ticking time bomb. The very features that made the RBMK reactor attractive to the Soviets were the ones that put it at risk. Little did the engineers know these design flaws would later contribute to the plant's downfall. Operating a nuclear power plant is no simple task, and Chernobyl was no exception. The heart of any nuclear power plant, Chernobyl included, is the reactor. This is where the magic, or rather the science, happens. The nuclear fission process, a chain reaction where uranium atoms are split to release a massive amount of energy, takes place here. In Chernobyl's case, the reactors were of a type known as RBMK, a Soviet-designed reactor notorious for its instability at low power levels. The control of this beast was a daunting task, requiring a constant balancing act. The control rods made of boron were used to control the nuclear reaction. They absorbed neutrons, slowing down the reaction, and could be raised or lowered to increase or decrease power output. The power generated through the fission process was used to heat water, converting it into steam. This steam then drove turbines, which in turn drove generators to produce electricity. It sounds straightforward, but the reality was a complex web of systems and subsystems. all working in harmony. The operators played a crucial role in maintaining this harmony. They were the maestros, directing this symphony of power production. They monitored various parameters, adjusted control rods, and ensured the safety systems were functioning correctly. It was a job that required precision, vigilance, and a deep understanding of the reactor's behavior. Every part of the operation was interconnected. A change in one parameter could have a domino effect, impacting several other aspects of the operation. The complexity was staggering, the margin for error almost non-existent. And yet, for a time, Chernobyl managed to operate successfully. It was a testament to the skill and dedication of the operators and the robustness of the engineering, albeit flawed in some critical aspects. But as we know, this success was not to last. Despite its intricate operation, Chernobyl functioned smoothly until the day it didn't. In the end, a combination of design flaws and operator errors led to the unthinkable, a disaster of catastrophic proportions. But that's a story for another time. The calm before the storm was unsettling, as the Chernobyl power plant hurtled towards disaster. As we delve deeper into our chronicle of Chernobyl, we arrive at the precipice of catastrophe. The power plant, a marvel of Soviet engineering, was about to bear witness to a calamity, a consequence of both human error and design flaws. In the early hours of April 26th, a safety test was scheduled, designed to simulate a power outage and assess how long the turbines would spin and supply power to the main circulating pumps. This was not the first time such a test was conducted. Previous attempts had ended in failure. The intention this time was to test a new voltage regulator design. However, the test was delayed by 10 hours, causing a shift change. The late-night crew, unprepared for the complexity of the test, found themselves in the throes of what was soon to become a nuclear nightmare. They were asked to carry out a procedure they were not trained for, a decision that would play a significant role in the impending disaster. The reactor was to be run at low power, around 700 megawatts. However, due to a miscalculation, the reactor power level fell to 30 megawatts, causing the reactor to become unstable. In an attempt to increase power, the operators removed too many control rods, violating safety regulations. Simultaneously, the design flaws of the reactor began to surface. The RBMK 1000 reactor had a positive void coefficient, meaning that as the steam increased, the reactivity also increased, leading to a surge in power production. This, coupled with the graphite-tipped control rods, created a deadly combination. As the operators scrambled to regain control of the power surge, the reactor was already on a runaway path. The combination of human error, unanticipated low-power operation, design flaws, and the violation of safety protocols was brewing a perfect storm. The stage was set for one of the worst nuclear disasters the world has ever seen. The clock struck 1:23 a.m. on April 26, 1986, and the world would never be the same again. This was the moment when the Chernobyl disaster began to unfold. But let's rewind a bit. Remember the design and operational flaws we discussed earlier. They've now set the stage for a catastrophe of epic proportions. The reactor's design was inherently unstable at low power levels. This, coupled with the operator's lack of understanding of the system's intricacies, led to a fatal series of events. The operators pushed the reactor into an unstable state during a late-night safety test. As power surged uncontrollably, the reactor's coolant started to boil, creating steam. Now, steam in a nuclear reactor isn't a good thing. It increases pressure and reduces the reactor's ability to cool itself. And remember, the Chernobyl reactor was already unstable due to its design flaws and low power level. The steam buildup led to an immense pressure spike, causing the reactor's first explosion. But the disaster didn't stop there. The first explosion exposed the reactor core to the atmosphere, causing a second, even more devastating explosion as the reactor's graphite moderator ignited. This second blast spewed radioactive materials into the environment, marking the beginning of a nuclear catastrophe that would affect millions. The Chernobyl disaster wasn't just a failure of technology, it was a failure of engineering, a failure to understand and manage the risks inherent in the system. The operator's mistakes and the reactor's design flaws combined to create a perfect storm, leading to a scenario that no one had prepared for. And what about the aftermath? Well, the reactor's core melted down, releasing an unprecedented amount of radioactive material into the environment. The surrounding area was evacuated and remains largely uninhabitable to this day. The disaster's long-term effects on human health and the environment are still being studied, more than 3 decades later. In the end, Chernobyl stands as a stark reminder of the perils of ignoring the risks in engineering design. It's a chilling testament to the importance of rigorous safety protocols, comprehensive operator training, and most importantly, thoughtful and robust engineering design.